it is not acceptable to connect a grounding and a neutral conductor to the same lug within a main electrical panel. This practice violates established electrical codes and poses significant safety risks. The primary reason for this separation lies in the fundamental differences in the roles and functions of grounding and neutral conductors within an electrical system. The neutral conductor, in a typical alternating current, that is AC, system serves as the return path for current flow. It carries the imbalanced current from the loads back to the source, such as the transformer. In a properly functioning system, the neutral conductor operates at or near 0 volts potential with respect to ground. The grounding conductor, on the other hand, is intended to provide a low impedance path for fault current to return to the source. It is designed to carry current only during abnormal conditions, such as a ground fault, where a live conductor comes into contact with a grounded surface. The grounding conductor's primary purpose is to facilitate the rapid tripping of overcurrent protection devices such as circuit breakers or fuses to quickly de-energize a faulty circuit and minimize the risk of electrical shock or fire. Connecting the grounding and neutral conductors to the same lug within a main panel creates a parallel path for neutral current to flow through the grounding system. This can lead to several undesirable consequences. Firstly, it can cause the grounding system to become energized under normal operating conditions. This means that metallic parts of equipment and appliances that are supposed to be at ground potential may now carry a voltage with respect to ground. This can create a shock hazard for anyone who comes into contact with these surfaces. Secondly, it can interfere with the proper operation of ground fault circuit interrupters, that is, GFCIs, and arc fault circuit interrupters, that is, FCIs. GFCIs and FCIs are designed to detect small imbalances in current between the hot and neutral conductors, which can indicate a ground fault or an arc fault, respectively. When neutral current is flowing through the grounding system, it can mask these imbalances and prevent the GFCIs and FCIs from tripping as intended, thereby compromising their ability to protect against electrical hazards. Thirdly, it can increase the risk of electromagnetic interference, that is, EMI. When neutral current flows through the grounding system, it can create electromagnetic fields that can interfere with the operation of sensitive electronic equipment. This can lead to malfunctions, data corruption, and other problems. The National Electrical Code, that is, NEC, specifically addresses the separation of grounding and neutral conductors in Section 310.10 of the 2002 edition. This section prohibits the use of a single lug for both grounding and neutral conductors within a main panel. The NEC mandates that each conductor must have its own separate termination point. This requirement ensures that the grounding and neutral systems remain isolated from each other, preventing the flow of neutral current through the grounding system and mitigating the associated risks. In addition to the NEC requirements, most electrical codes and standards around the world also emphasize the importance of separating grounding and neutral conductors. These codes and standards are based on sound engineering principles and are designed to protect people and property from electrical hazards. When working with electrical systems, it is crucial to adhere to all applicable codes and standards and to follow best practices for electrical safety. This includes ensuring that grounding and neutral conductors are properly separated and terminated. If there is any doubt about the correct way to wire an electrical system, it is always best to consult with a qualified electrician. In summary, connecting a grounding and neutral conductor to the same lug within a main panel is a dangerous and code-violating practice. It can lead to energized grounding systems, interference with GFCIs and FCIs, increased EMI, and other problems. The NEC and other electrical codes require that grounding and neutral conductors be kept separate and terminated at separate points. Following these requirements is essential for ensuring electrical safety and protecting people and property from electrical hazards. The separation of grounding and neutral conductors extends beyond just the main panel. The NEC outlines specific requirements for how these conductors are handled throughout the entire electrical system. Here are some additional points to consider. Firstly, at the service entrance, the neutral conductor is typically bonded to the grounding system. This bonding point is usually located at the main panel and is often achieved by connecting the neutral busbar to the metal enclosure of the panel. This bonding ensures that the neutral conductor is at the same potential as the grounding system, which helps to minimize voltage differences and reduce the risk of electrical shock. Secondly, downstream from the service entrance, the neutral and grounding conductors must remain separate. They should not be connected together at any point other than the designated bonding location at the service entrance. This separation is crucial for preventing the flow of neutral current through the grounding system. Thirdly, in branch circuits, a separate grounding conductor must be run along with the hot and neutral conductors to each outlet and device. This grounding conductor provides a low impedance path for fault current to return to the source, facilitating the rapid tripping of overcurrent protection devices in the event of a ground fault. Fourthly, equipment grounding conductors, that is, EGs, are used to ground the metal enclosures of electrical equipment and appliances. These EGC are typically connected to the grounding busbar in the panel and run separately from the neutral conductor to each piece of equipment. The EGC ensure that the metal enclosures are at ground potential, reducing the risk of electrical shock if a live conductor comes into contact with the enclosure. Fifthly, isolated ground receptacles are sometimes used in sensitive electronic equipment installations. These receptacles have a separate grounding conductor that is isolated from the normal building grounding system. This isolation helps to reduce noise and interference that can affect the performance of the equipment. When working with isolated ground receptacles, it is important to follow the manufacturer's instructions and to ensure that the isolated grounding conductor is properly installed. Sixthly, the size of the grounding and neutral conductors must be appropriate for the size of the circuit. The NEC provides tables that specify the minimum size of grounding and neutral conductors based on the size of the ungrounded conductors. It is important to consult these tables and to use conductors that are large enough to safely carry the expected current. Seventhly, grounding and bonding connections must be made with approved methods and materials. The NEC specifies various types of connectors, clamps, and other hardware that are suitable for making grounding and bonding connections. It is important to use these approved methods and materials to ensure that the connections are reliable and corrosion resistant. Eighthly, regular inspection and testing of grounding and bonding systems are essential for ensuring their continued effectiveness. Grounding and bonding connections can become loose or corroded over time, which can compromise their ability to provide a low impedance path for fault current. Regular inspection and testing can help to identify and correct any problems before they lead to electrical hazards. Ninthly, in addition to the NEC, other standards and regulations may also apply to grounding and bonding systems. For example, the Institute of Electrical and Electronics Engineers, that is, IEE, publishes standards that provide guidance on the design and installation of grounding systems for specific types of facilities. It is important to be aware of all applicable standards and regulations and to comply with them. Tenthly, working with electrical systems can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always to energize circuits before working on them, and use appropriate personal protective equipment, that is, PPE, such as rubber gloves and safety glasses. If you are not qualified to work on electrical systems, it is best to hire a qualified electrician to do the work. Understanding the importance of separating grounding and neutral conductors and following the NEC requirements is essential for ensuring electrical safety. By adhering to these guidelines, we can create safer electrical systems and protect people and property from electrical hazards. The NEC Section 310.10 is just one piece of the puzzle when it comes to understanding grounding and bonding. There are many other sections of the NEC that address these topics, and it is important to be familiar with them all. Here are some additional NEC sections that are relevant to grounding and bonding. Firstly, NEC Section 250 covers the general requirements for grounding and bonding. This section provides definitions, rules, and guidelines for grounding and bonding electrical systems. Secondly, NEC Section 250.24 specifically addresses grounding of service-supplied alternating current systems. This section outlines the requirements for grounding the neutral conductor at the service entrance. Thirdly, NEC Section 250.28 covers bonding jumpers. This section specifies the requirements for bonding metal enclosures, raceways, and other non-current carrying metal parts of the electrical system. Fourthly, NEC Section 250.30 addresses grounding separately derived alternating current systems. This section outlines the requirements for grounding systems that are derived from sources other than the utility service, such as generators or transformers. Fifthly, NEC Section 250.50 covers grounding electrode systems. This section specifies the requirements for grounding electrodes, such as ground rods, ground plates, and metal water pipes. Sixthly, NEC Section 250.64 addresses grounding conductor connections. This section outlines the requirements for making reliable and corrosion-resistant connections to grounding conductors. Seventhly, NEC Section 250.92 covers installation of equipment grounding conductors. This section specifies the requirements for running equipment grounding conductors in raceways, cables, and other wiring methods. Eighthly, NEC Section 250.96 addresses bonding other enclosures. This section outlines the requirements for bonding metal enclosures that are not required to be grounded. Ninthly, NEC Section 250.102 covers grounded conductor for alternating current systems. This section specifies the requirements for the size and installation of the grounded conductor, that is, neutral conductor. Tenthly, NEC Section 250.118 lists the types of equipment grounding conductors that are recognized by the NEC. These are just a few of the many NEC sections that are relevant to grounding and bonding. It is important to consult the NEC and to understand all of the applicable requirements before working on electrical systems. In addition to the NEC, there are also other resources that can provide guidance on grounding and bonding. These resources include, firstly, the IEE standards, which publish standards that provide guidance on the design and installation of grounding systems for specific types of facilities. Secondly, the National Fire Protection Association, that is, NFPA, which publishes the NEC and other codes and standards related to electrical safety. Thirdly, Underwriters Laboratories, that is, UL, which tests and certifies electrical products to ensure that they meet safety standards. Fourthly, manufacturers of electrical equipment, which often provide detailed instructions on how to ground and bond their products. Fifthly, qualified electricians who have the knowledge and experience to design, install, and maintain grounding and bonding systems. By consulting these resources and following the NEC requirements, we can ensure that our electrical systems are properly grounded and bonded, which will help to protect people and property from electrical hazards. Remember that electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always de-energize circuits before working on them and use appropriate personal protective equipment. If you are not qualified to work on electrical systems, it is best to hire a qualified electrician to do the work. A proper grounding system is essential for the safe and reliable operation of any electrical system. It provides a low impedance path for fault current to return to the source, facilitating the rapid tripping of overcurrent protection devices and minimizing the risk of electrical shock or fire. A proper bonding system ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electrical shock if a live conductor comes into contact with a metal enclosure. By following the NEC requirements and consulting with qualified professionals, we can ensure that our electrical systems are properly grounded and bonded, which will help to protect people and property from electrical hazards. It is important to remember that the NEC is a minimum standard, and that in some cases, it may be necessary to go beyond the NEC requirements to ensure electrical safety. For example, in areas with high levels of lightning activity, it may be necessary to install additional lightning protection measures. In facilities with sensitive electronic equipment, it may be necessary to use isolated ground receptacles or other specialized grounding techniques. The key is to assess the specific risks and hazards of each electrical installation and to implement appropriate grounding and bonding measures to mitigate those risks. Grounding and bonding are not just about complying with the NEC, They are about protecting people and property from electrical hazards. By understanding the principles of grounding and bonding and following the best practices for electrical safety, we can create safer and more reliable electrical systems for everyone.